Chapter 1.4 Fundamental Concepts for Understanding Natural Processes as Hazards. Science helps us understand the causes of natural hazards. This is done through investigation using the scientific method. A question is asked, followed by background research, followed by the formation of a testable hypothesis, usually a statement that can be found to be true or false. Design an experiment to test the hypothesis, analyze the results, and make a conclusion. Is your hypothesis true or false? Report your hypothesis, experiment, and results so that everyone knows about it and can repeat your work if they want to. For an example of the scientific method, let's look at the picture of a large boulder in the road. My questions are, why is there a boulder in the road? Where did it come from? Do boulders frequently fall on this road? Does the weather influence boulders falling on the road? Was anyone hurt? What is the economic cost? Next, I would need to do background research and find out all that is already known. Let's say that in doing my background research, I find out that boulders, smaller rocks, and soil frequently fall onto the road after significant amounts of rain, and that the economic cost is several million a decade to keep the road open and repair electrical lines. No one has been hurt yet. But this road is the only road between a small town and the nearest moderate-sized city. The small town is mainly supported by logging. My background research helps me think of more questions, such as, does logging influence the landslide area along the road? Is there a better route for the road? Etc. Then I would narrow my questions down and form a hypothesis. An increase in logging has led to an increase in the number and size of landslides along this route. My designed experiment may involve such things as statistics and logging maps, and of course, I would provide a detailed report of all my methods. After looking at the data and analyzing it, let's say that I find an increase of logging in the area does correspond to an increase in landslides along the route. I then report my findings in a peer-reviewed journal, as well as other more publicly accessible venues. People with logging interests may not be happy with my results, so I would be sure to be diplomatic and rational stating and defending my results. Using this knowledge, a community could take steps to mitigate the landslide hazard along the route. Options could vary from signage to closing the road to curtailing logging to stabilizing the slope, etc. The type of mitigation chosen would depend on several factors such as risk, which we will talk about later in further detail, and available funds. The degree and type of mitigation possible varies from type and magnitude of the hazard. A little flood can be controlled. A big flood can only be avoided. A volcanic eruption or an earthquake cannot be controlled at all. Using what we know about the past occurrence of natural hazards, we can try to forecast, predict, and warn of future natural hazards. Two concepts play heavily in forecasting and predicting hazards: uniformitarianism and environmental unity. Uniformitarianism is the idea of the present is the key to the past, or flipped around, the past is the key to the present. Look at the image of geologic time with important events. Under the events column, there is a life column and an earth column. Notice any repeats in the life column? There are several extinction events throughout history. How about in the Earth column? There are ice age events throughout Earth's history. What prediction can you make about the Earth's future? Environmental unity is the idea that the entire Earth is a system, and that if you change a part of the Earth, then other parts of the Earth system will change. Everything is linked. An example: if we cover soil with asphalt, we've changed the infiltration of water into the soil, which changes the drainage of the soil into streams, which changes the stream quality and the type of life that likes to live in the stream. Change causes change. Hopefully, we are in a position to try to invoke the type of change that we want, right? We can use this concept in mitigation. Another important aspect to mitigation is prediction and forecasting. A prediction of a natural hazard involves specifying a date, time, location, and size of an event. A forecast gives ranges of certainty. Prediction is harder than forecasting for all natural hazards. Some hazards, a prediction is impossible. No one credible says with certainty that a magnitude 5 earthquake will occur on October 18th at 7:02 p.m. along the Salt Lake City segment of the Wasatch Fault. But credible people can say a magnitude 5 earthquake is likely to occur along the Salt Lake City segment of the Wasatch Fault in the next 500 years. Precursor events help with prediction and forecasting. These are events that happen prior to the natural hazard itself. Let's see if you can think of some. What is a precursor event for a flood? Rain is one possible answer. What is a precursor event for a volcanic eruption? Small earthquake swarms is one possible answer. How about a wildfire? Dry conditions is a possible answer. Get it? These predictions and forecasts can stimulate warnings for the public. A public warning should follow path below, from data to scientists, to prediction and forecast review group, to officials and the public, and then a warning from officials to the public. Predicting and forecasting the future is uncertain, tricky work, and there is never enough data. When should a warning not be given? How certain would the prediction need to be for you to want to know? How often does a false warning need to be given for you to stop heeding any warnings? These are open-ended questions that are open for community debate.